Hello and welcome back. In this chapter, we're going to go through a realistic scenario in which you might use Docker. We're going to deploy a fairly complex Java Tomcat application to our local development machine, hopefully without having to do too much work. I admit that the previous chapter was probably quite painful for some of you, depending on which operating system you're running on. But I hope by now the position you're in is that either on your PowerShell, if you're running Windows 10 Professional, or on your terminal, if you're running on Linux, or macOS from Yosemite 10.10.3 onwards, or you'll be using the Docker Quick Start terminal if you're on older versions of Windows or older versions of macOS. Either way, you should be on some kind of a command line and you should be able to type docker container run followed by hello-world, and you should see output like this, and definitely no errors. If you've got that far, then you can start to reap the benefits of Docker. And I thought what we'd do on this course, rather than me plowing through endless commands and going into deep technicalities about how Docker works, I'd rather sort of use Docker in the way that you might be using Docker in a real live environment. So I have a made-up scenario here. We're working in an operations team now. I know that many of you will be working as DevOps, where you're both a developer and you're working in operations, but I think for the course it's useful to distinguish the roles of developer and operations. So we're working in operations and we've had an email. And the email says that this developer has finally got something working on a web app that they're developing. If you've been on the previous Virtual Pair Programmers course for deploying microservices, then you'll be familiar with this web app. Actually, we developed this originally on the Spring Boot course. It's a fleet manager that tracks vehicles. Now, apparently, the developer has now got the vehicles animated and they can now move on the web page, and they want us to test their changes. How are we going to do that? Well, they've given us two pieces of information. They've told us, first of all, the image is called Virtual Pair Programmers /Fleetman-web app. And they've given us a link to some kind of a file called the Docker file at the URL you can see here. And they're asking us to run it. And if it runs okay, they'd like us to try to run it on an EC2 instance and give them the IP address. So I know I went through this in the introduction chapters, but we don't really know much about this application. I guess we could inspect the source code if we went across to this GitHub repository, and we could work out that it's a Tomcat application, it needs a WAR file, it's using a database, we need to configure that database, we need to open up the ports, etc., etc., etc. And you all know what kind of a nightmare that is. But you know that we're using Docker, and I've gone through the concept of images, and that's clearly what we have here. And we know that an image is a definition of a container. And the image is going to contain all of the software and the environment needed to run this application. What I didn't tell you was that all images have names, and this is the name of the image that the developer has built. What can we do with that name? Well, we can download that image. And the command to do that is docker image pull followed by the name of the image. And that was Virtual Pair Programmers /Fleetman-web app. So you should be able to follow along with me. And on issuing this command, you should see a download happening. So clearly what's happening here is somehow these images that I've been talking about are able to be distributed really easily. You haven't had to kind of download this image from a website or anything. You've just put in this label, and somehow Docker is able to find that image and start downloading it. Now, of course, I'll be giving you the full details about how all this works later on in the course, but for now, I think it's probably just enough to know that, hey, yeah, we can, as long as we know the name of an image that somebody has created, we can simply download it by using Docker image pull. Now, while that's downloading, I will say that probably the hardest thing about working with Docker is remembering this long list of commands. And it is going to feel on this course like I'm throwing loads of commands at you. So for that reason, I'm going to gather all of these commands together and I'll put them in an easy reference guide that you can download as part of this course. So that's one command we've got now, Docker image pull. Okay, well, we've downloaded that image, so what can we do with it? Well, as described in the introduction, what we want to do with an image is run it. And when we run an image, it will become a container, a self-contained complete environment that's running some kind of software. Before we try that, there is one little bit of information that the developer gave us, which is the Docker file is at this URL here. And you can follow that URL if you want to, but you don't need to because I've mounted it onto this caption. We'll be looking at this Docker file in great detail later on in the course, and you will be writing your own Docker files. But for now, it's enough to know that a Docker file is what we use to define the contents of an image, and therefore the Docker file determines what's going to be in the ultimate running container. Now, there's quite a lot of information in here that isn't really of relevance to us right now, but there are a couple of important pieces of information that we need as deployers. The first line is here, this expose 8080. Now, I'm assuming that if you're on this course, you're familiar with Java web development, and you'll recognize 8080 as the common port that Tomcat runs on by default. And effectively what the developer is telling us here is that they want Tomcat to run on port 8080 inside this container. Without this piece of knowledge, we wouldn't know what port the developer wanted it to run on. The other piece of information is the part here that I've emboldened. This is where the developer is specifying how they want their war file to be deployed to the running Tomcat inside this container. And the only reason this is of interest to us right now is we need to know the name here. Again, I'm assuming you're familiar with this from Java web development. The name of the war file here will become the context under which this application is going to run. And we need to know the name of that so we know what to type in on the browser when we actually visit this running application. Now, if there'd been anything here other than root, then we would have to include that name in the URL. However, I don't know if you know this, we must have done it on previous courses, but if the war is called root, capital letters, .war, then it becomes the root application, and we can just visit this application via its domain name or IP address. We don't need to put a / followed by some kind of a name. So that's definitely of relevance to us. Without that, we wouldn't have known how to visit this application. Quite a lot to learn about Docker files later on in the course, but for now, we actually know enough to be able to run this image. To run an image, we need the command docker container run, followed by the name of the image that we're running. So that's going to be virtual pair programmers / fleetman-web app. Before I run that command, there's something very important that we need to do. We know from that Docker file that inside this container, we're going to have an Apache Tomcat running on port 8080. But it's really important to understand that that port 8080 will not be visible from outside the container, or at least by default. The components inside the container, let's say we had, I don't know, say a database server running inside this container, that database server would be able to contact Tomcat on port 8080 because it's running inside the container. But from outside the container, these ports are not visible. They're not published. Now, that's a nice feature, actually, of Docker, because it means that at deployment time, in other words, when we're actually running the container, we as deployers get to be able to choose which parts of the container are going to be exposed to the outside world. It's actually a pretty neat security feature. So what we need to do when we run the container is we need to publish ports. So we need to somehow say that if we have a browser trying to access this container and it accesses port 8080, well, we want that traffic to be forwarded to the internal containers port 8080. And we do that as part of the command. So I haven't run this command yet, but I'm going to back up to just after the run part. And we do this through command line arguments. And the argument is -p, which actually stands for publish. And what we do with this is we say, which port do we want to expose to the outside world? In that case, for us, this is 8080, followed by a colon, followed by the internal port inside the container that we want to forward that traffic to. So this means if in a browser I type in IP address :8080, that traffic will be directed to the Tomcat port inside the container. And that, until we get a little bit more advanced, is all we need to run a container. If you're following along with me, let's give this a try. And you should recognize from here what looks like definitely a regular Java Web Apps logging, but we can see from here this looks like a Spring Boot application. And there's some Hibernate logging going on in there. So something to do with databases, even though we haven't configured a database ourselves. It might take a while to start up. For me, it took about 30 seconds. Depending on the speed of your machine, it might take longer. Now, of course, because I've just given you this image, we don't know how complicated the image was, but I want you to take a step back and really think about, we didn't have to do any configuration other than that little bit of work in publishing the appropriate ports. We should now be able to visit this in a browser. Now, depending on which version of Docker you have installed, you might be able to, in your browser now, visit localhost :8080, the port that we've published, and that's it. Because we know from the Docker file that the application has been deployed to root.war, therefore there's no subfolder like Fleetman web app or anything like that. If you have been on earlier courses where you've developed this Fleetman application, I have slightly re-engineered this to remove the rather complex URL schemes that we had in there. I've made the front page be as it should be, just on the /. So that is working for me. I'm seeing a running application. Now, if you're running on Docker Toolbox, so that's if you're on Mac or Windows, then you're probably not getting anything at this stage. And that's because the virtual machine that you're running on, remember, Mac and Windows are all using virtual machines for the Linux kernel. The IP address of that virtual machine is not actually mapped to localhost. What you need to put in here is actually the IP address of your virtual machine. So how do you find that? Well, again, you can get that from the command line, and I'm going to have to do a Control-C. Pressing Control-C on the PowerShell does not kill a container. It actually leaves it running in the background. But that gives me a chance to show you some extra Docker commands. Again, these are all going to be in the PDF document that you can download as part of this course. If you do a docker container ls, that's going to list all of your running containers. So we can see here that we have a container ID, which is some kind of random generated ID number. There's the image that the container was created from. We'll think about the command later. The lifetime of the container, mine's been up for 13 minutes. And there's the port mapping. And finally, we have a name. Now we can give every container that we run a unique name if we wish to do so. We will need to do that shortly, but for now it really doesn't matter what the name of the container is, so we will get one automatically randomly generated by Docker. And just in case you're interested, the random generation is some kind of adjective, a describing word, followed by, I think they have a long list of surnames of famous and notable people. So you may well recognise some of these surnames. The name's not important for us right now. So we'll leave the container running in the background for the moment, but now I'll show you how to get the IP address if you're running on Docker Toolbox. You can do docker-machine IP. Now for me, that's not going to give me any, well, it's actually giving an error, and that's because I'm using Docker for Windows. But on the Docker Toolbox, you should see an IP address in there, which you'll be able to use in your browser instead of localhost. So if you do have an IP address here, then copy that in and paste it into your browser, :8080. Before we move on, a couple of things I'd like to do. So we've seen that we can do a Docker container ls, which will show us a list of all of the running containers. I guess it would be useful to show you how to stop a running container. Well, we do that with Docker container stop, and you can put in now the ID of the container. Now, the ID of the container is quite a long, random generated string of characters, but you're allowed to enter the fewest number of characters that uniquely identifies this container. So I think actually we could just say Docker container stop 4. Now, I personally like to put in at least the first couple of characters of that ID. So 4C would do it, or 4C8 would certainly do it. Just to show you that 4C is sufficient, I don't see an error message there, and we just get echoed back the ID of the container that was stopped. Of course, yours almost certainly won't be 4C, so just substitute in as required. And if we run Docker container ls again, you can now see that we have no running containers. If we go back to the browser and do a refresh here, remember, if you're on Docker Toolbox, you'll need an IP address in there. Then, yeah, the site can now not be reached. Now, I wanted to do that just to show you that if I recall the command that ran the container, I want to focus in on this publishing of ports. Now, we know now that the left-hand number is the external port. That's the port that's been entered in the browser, and this is getting forwarded to the internal port number inside the container. Well, you're probably not surprised to learn that we can use really any number here. I've just used a random port number of 8161. Now, what this means is that although Tomcat internally will be running on 8080, the external publish port is now going to be 8161. Let's try that. So just to check, if we visit the old port number of 8080, we know that Tomcat is running on port 8080 inside the container, but it's not visible to the browser. But if I change that to 8161, then wonderful, 8161 is being forwarded to port 8080. So the really important thing about this is that means if I do a Control-C, I'll repeat the process of doing a Docker container ls, and we'll do a Docker container stop on that container ID, for me beginning 95, and then I'll go back to the run command. The really important aspect of this is if I didn't do that -p, then that port 8080 would not be exposed to the outside world, a very important security measure. But it also means that we could be a bit professional here. If we did a -p and we forwarded port 80 to port 8080, then of course we have the nice situation where we don't need a port number at all, because the default port 80 is now automatically forwarding to the internal port 8080. So that's quite nice. Well, going back to the requirements for this exercise, the developer says if this looks okay, and I think it does, they want us to throw it onto an EC2 instance and then tell them the IP address. And you don't need to follow along with me here if you don't have easy access to an EC2 instance. If you do want to follow along and you've never used EC2 before, then I recommend the Virtual Pair Programmers course called Cloud Deployment with AWS, and we take you through the basics of that. So I have here an EC2 instance that I started up earlier. In fact, it's the one I used to demonstrate installing on Linux. So we should find we have just a quick test of the Hello World image, shows that Docker's up and running okay. And really, the purpose of this exercise is just to show you that even though we're now on quite a complicated cloud platform, the command is going to be identical. Docker container run -p will do 80 being forwarded to 8080 again, and the image name is virtual pair programmers /fleetman-web app. Now you might be thinking, oh, hang on, we haven't done a pull. Turns out you actually don't need to do a pull, because if we don't have a copy of the image here on this machine, it will automatically go and do a pull anyway. So if we run that command, yeah, you can see they're unable to find the image locally. It's now doing a download. It's a fairly sizable download. Of course, it's having to download a Tomcat, a Java virtual machine, and the WAR file are all part of this image. So there is quite a lot in the image. And we're now seeing what looks exactly the same logging as we had locally. And I know that the IP address of my EC2 instance is the IP address here. And we should now be able to simply visit that IP address. And if you're following along on EC2, you will need to make sure that your security group for that instance allows traffic from port 80. But you didn't need to follow along. I just wanted to demonstrate that the process of deploying there was identical to the process of doing a local test. And that's the point of Docker, to make our development environments and really every environment that we work in identical. We're just running containers, and the containers are from the same images. This isn't quite professional yet because we'd need to make this some kind of a daemon process, but I hope that little exercise has given you a flavour for what Docker can do for us. Over the next few chapters, we're going to go into a little more detail on what's going on here, and in particular, we're going to see how to make our own images from scratch. So I'll see you in the next chapter.